Fabrications coming to you. This topic is STEM. And I guess for you guys tuning in, the sophomores, just the word STEM hits such a broad topic. I mean, that's anywhere from marine biology to the help desk guy with computers to engineering to a whole host of things. So we can't hit all of it, but we do have two speakers in today from a place called Emerging Technologies and a place called Broadwind to speak about engineering. And my job is just get them started and get out of the way. So we're going to turn it over right now to Mark.
All right. Well, good afternoon, everybody. My name is Mark Van Steenberg, and I am president and founder of a company called Emerging Technologies. So I'm going to tell you a little bit about what my role is like at Emerging Technologies, and maybe partway through my discussion, I'm going to switch gears and talk a little bit about the type of people that work for Emerging Technologies and what entry-level positions might be like. So as far as my workday goes, as I mentioned, I'm president of the company, so I have a lot of different responsibilities and wear a lot of different hats. I work generally a 9 to 10 hour day, and on occasion nights, weekends, or whatever is required to keep things working. I've been at it for about 35 years, and about 22 years of that has been since I started Emerging Technologies. So I work my job is primarily these days is a desk job. But it does include some travel, and most of the engineering folks here at Emerging Technologies will have to go out to customer sites and things like that to work on equipment or get things started up or solve problems in the field. And so I'm kind of working from a question list here that was provided, but I'll get into some of my own discussion as well. They asked, is there any risks in my job? Well, we work with electricity here, and some of the test equipment that we build is like for simulating lightning strikes and things like that. So we build systems that run up as high as 400,000 volts and up to 80,000 amps. So those are the risks in our role, is you have to really understand what you're doing when you're working around the high power equipment to make sure you not only don't touch it, but don't get close enough to it that it finds you as an attractive lightning strike. So I would say that is the risk aspect of my job. But like I said, I work mostly at my desk, and we work with crews of teams. So we have project teams that are assembled based on each order that we get in. So when we design and build a piece of equipment, there's usually a project leader, and there might be electrical engineers and programmers and fabrication resources, and we'll do the design, build, and deployment of a piece of test equipment. So it involves several different resources working together, and teamwork is certainly a key aspect to what we do. We also get the question, what is it that you like about your job? Well, it's easy for me, right? Because I own the company. I like everything about it. But in terms of the average person that is involved with Emerging Technologies, I think what we find most typically is we stem off of a standard degree that you can get in the field, primarily electrical engineering or computer programming. And then we move into a field that isn't real typical. So most of our resources are referred to as test engineers. Well, you can't go to school to become a test engineer. You have to start somewhere else, and you get an electrical engineering degree or a computer programming degree, physics. A lot of our guys have physics background, and mechanical engineering, or even chemical engineering. And then they migrate into the test field as a test engineer. So it's hopefully the people watching will find this interesting, because it's kind of an unusual variation off of the electrical engineering field. But the part that's the most fun about it for me is that it's something new and different all the time. We're not just, while we always build test equipment, we're always designing, building, and deploying the same thing in that respect, that it's test equipment. It's always a different product we're testing, and it's always different technology, and sometimes it's high voltage, sometimes it's high current, sometimes it's low voltage or low current. It might be a circuit board or a sub-assembly to some other larger pieces of equipment. So it's applying the theory and the things that we learned in school to different situations in the development of the equipment and in the field and the deployment of the equipment. What was high school like for me? Well, I was a shop kid, and I took every electricity class I could take. I took every shop class I could take. I took all the machining, I took all the woodworking, everything I could take to learn how to use my hands and make things. And then when it came time for formal education, I remember the day that I sat down with my counselor to talk about, what was the thing I should do and how should I go forward. Well, I had this quandary between the things I most enjoyed doing and what it was going to take to support myself and a future family and whatever my endeavors might be. Well, finally, we backed our way into electronics and electricity because I was interested in that. I really liked cars and motorcycles, but I couldn't envision myself with greasy hands every day, even though I enjoy that. So I decided to go into electrical field. So I got a degree in electrical power. I went to school locally at, well, it was then Lakeshore Technical Institute. Today would be Lakeshore Technical College. So I have a degree in electrical power. And then I took that and went and found whatever job I could find. You know, I had several different jobs. I started out in maintenance and went into calibration and maintenance, and then started to get into design and into engineering. Ultimately managing different business units for the company I worked for, which led to me starting this company in test systems. So I hate to make the story long and boring, but I like to illustrate the fact that along with the formal education, that the drive, you know, is what makes a difference, right? Regardless which level of education you decide to go with, which path you head down, those opportunities would be there for those individuals, you know, that know how to apply themselves. So in terms of other classes that were specifically good in this field of interest for high school, you probably couldn't have convinced me then, but certainly you can now, was, you know, well, math probably I agreed with at that point. Math, science, English class, believe it or not. You know, I was a class, I thought, why would I ever need to take that, right? Well, in my role now, I deal a lot with contracts and proposals and a few things that might be of interest. I'll try this. So hopefully, do you guys see my screen now? Oh, not yet. How about now? Can I get the moderator to tell me if you can see my screen, or you still see me?
Yes, I can see emerging technologies and innovative test solutions is on your screen.
Okay, so so this is just a simple brochure for our company, but I thought I would show it to get some interest in understanding what we do. You know, there's some unusual pictures right on the front page. And I'll scroll here to the next page. This is the type of industries, and so this is an example of a electrical substation you might see driving down along the highway. And then these other pictures off around here, this is actual test equipment that was designed, built, and deployed here at Emerging Technologies. So a lot of electrical stuff going on here, a lot of computer programming. And if you're a quick read here, you can see some of the industries that we're involved in. And I'll flip here to the next page just for fun. That's me sitting there, good looking guy right there. And then this is part of our crew sitting in the conference room, and we've got some scheduling software up on the big screen. And you know, there's an area where we meet, and we're using project schedules. We're using, you know, electrical diagrams, mechanical diagrams, you know, programming examples, and we do a lot of conference calling, like we're doing today for this presentation, there from our conference room. And then, you know, we're not a big company. We've got, I think, 12 technical resources here, and we build a few $1 million a year worth of test equipment. And then I can switch to one more screen here. So this is an example. I talked about technical writing. Well, this is an application brief that was written here. It's a 2-page document that is used to for us to share with customers that explain the kind of projects and things that we're doing. So if there are people that have interest in better understanding, this isn't really a sales pitch, but emergingtech-llc.com is our website. There's all kinds of these on there. And as you can see here, you know, this whole assembly line here was designed, built, and deployed by Emerging Technologies. So all that equipment, you know, everything from these cages, these metal cages here, these electrical control panels, and the conveyor line in the background, that was all conceptualized here, and involved all the disciplines of engineering that I talked about previously. I think at that point, that probably brings me up pretty close to my initial time. And I don't know if we have questions from anybody but the moderator at this point. But.
Yeah, let me just throw one to you, Mark. The question I have is, you know, electrical engineering is kind of the mainstay of the company. Of course, you know, people come working with computer programming degrees, physics backgrounds, things like that. But when you put out when you put out job openings, do the majority of your job openings ask for a 2-year degree, a 4-year degree, an either or type thing? And I know it's going to be different per job, but as far as if you could save on the majority, what would you be looking for?
Well, we're sort of an all of the above organization. The if I had to pick, I guess I would say the majority of our people are on the technical side of the business, have 4-year degrees, and most typically engineering or engineering related. I mentioned computer programming, but all of our manufacturing technicians in the shop that are doing the designs and the builds and the troubleshooting generally will have most likely a 2-year degree. We do have some that come directly from high school that have good shop background. On the administrative side of the business, we have a full mix. So as I mentioned, the thing that might be special about our business over a large company is that we're looking for the individuals that have committed to some training and show the discipline that they understand and can learn, and are committed to success, probably more so than the specific degree. But depending on what aspect of the business they're operating in, there certainly are some more specific requirements, and certainly some of the things we do require us to have degreed individuals. And we also have people with master's degrees. In my opinion, it's been good for us to have, say, an engineering resource that's gone on and got like an MBA or something like that. So as we get into the more leadership roles, to have an MBA is really useful, because then you start to understand things like purchase orders and invoices and project schedules and ordering of materials and the things that go along to support the engineering and manufacturing process.
Yeah, appreciate that very much. So I guess from there, we're going to move on from Mark up to Dennis. Dennis is with Broadwind, and just take it away.
All right. Thanks, everybody.
Good morning, everybody. I want to do a screen share right off the bat here, right off this the start. Let's see if I get this right. Okay. All right. Can you guys see my screen? I guess that's my first question.
Mm-hmm. Yes. Yes.
Okay, but which one are you seeing? Are you seeing the big one, or are you seeing the small one?
Well, there's both. There's on one side, there's engineers make a world of difference, and on the right side, there's more of a caricature with there's characters in it.
Oh yeah, we don't. I just want to have the main slide here, so I might go to the because I'm not sure how that works with Zoom. I know how I can do it with.
It's okay. It's not really that distracting if it doesn't go away, so that's fine.
Okay, we'll go with this one. So
right.
Here you just see the main slide. This is a PDF. Okay, so sorry for that little technical glitch, everybody. Very happy that everybody's here this morning. And Mark, I want to thank you a lot for going first. And I wanted to mention that some of my career has been involved in large automated assembly systems that included test as well. And I can promise you all that are listening today that getting into that field and involved with inspection systems like that and testing systems, there's no limit to the amount of variety that you can apply your creative talents to in solving problems. It's a great, exciting area to be in. So what I wanted to touch on here initially is just make some broad comments about engineering and the profession of engineering, and then finish up with giving you a little better idea of what Broadwind does here in Manitowoc. Engineers really do make a world of difference. The shuttle there is probably one of the best examples that everybody can relate to about engineering and all the various disciplines within engineering. I actually worked on the shuttle years ago. I guess that kind of dates me. But if we didn't have engineering, things wouldn't be quite so well. We'd still be back in the Flintstone era, which I don't think anybody would really be that happy with. We've gotten too used to all of the conveniences that we have these days versus a long time ago. If you think about it, though, what would things be like today? What can we thank engineering and scientists and physics and that for? And you wouldn't have that iPhone in your hand that you've become so very attached to. We wouldn't have the laptops that we have. We wouldn't have all the games video games and so on that we get to play. Television, you name it. All of the things that we take for granted today in the modern world have all come to us because of science and technology. So it plays a pivotal role. But one of the things I wanted to emphasize today, and Mark touched on it earlier, he made the comment that it's more than just math, and that's terribly important to recognize, because I feel like a lot of people shy away from STEM careers because they think, I can't do the math. We'll talk about that in a little bit. Engineering has a tremendous range of disciplines. They include information technology, computer engineering, environmental engineering, mechanical, electrical, you name it. There's this wonderful variety of disciplines within engineering that you can get yourself involved in. So if you're thinking about engineering, try to keep a very broad perspective. If you're only aware of a certain kind of engineering, please be aware that there's a tremendous variety, that you may not be interested in mechanical. Maybe you're more of a computer person. Well, there's careers within engineering related to computers, a lot of them. And not just different disciplines, a tremendous variety in disciplines, but there's a tremendous variety in industries that you can work in and be an engineer or a technical person. And I'm just trying to convey that here. You know, you can be in civil engineering working on bridges and roads. You can be in the petrochemical industry and find yourself working on equipment or designing equipment or processes to extract oil or minerals from the ground, construction, surveying, you name it. There's this wonderful variety. And that's what makes engineering, a career in engineering, so unique, I think, relative to virtually any other career you could choose. It is a tremendous variety of disciplines and industries you can get involved in just getting a basic engineering degree, because it teaches you problem solving that can be applied to just about anything. What are the characteristics of a typical engineer? This is where I wanted to get back to something Mark said, and it's not even really on this slide so much. It's more than just math. You need to be able to communicate with other people. You need to be able to articulate your thoughts. You need to be able to write. Literature, writing, English, communication skills, collaboration skills, working with other people, quite frankly, is every bit as important, if not more important, than the math, in my opinion. You need to like discovery, of course. You need to like problem solving, because there's no limit to the problems you can get involved in solving. Most important, perhaps, a natural curiosity, because that natural curiosity is what gives you the motivation and the perseverance to not just get the career, but to flourish in that career. What about math? There's a lot of misconceptions about math. Is it a core part of engineering? Yes, of course it is. But quite frankly, I would argue that if you were to talk to 100 engineers, more than half of them would tell you they really don't use that much math. You know, in Mark's business, they may use more math than they do in my business. But even in the business I'm in, we do use some math, but there's a lot of other activities that we have to get involved in that you're not doing calculus, frankly. In fact, you do very little in a lot of engineering careers. So I want to make sure people know that, yeah, sure, it's an important part of the curriculum, but being a math expert is not what's going to make you a very accomplished and successful career in engineering, unless you're very much focused in a specialist in a very narrow area. So another thing I wanted to highlight, why it's important to be in a STEM career. If you think about all those things we talked about earlier, the things that have made the standard of living that we have today, the cell phones, the computers, the airplanes, everything that we take for granted. So all of that is one way or another come out of science and technology. The standard of living we have in the United States is a result of all those people that have come before us in these careers. Moving forward, all these other countries have seen the success of the United States. They realize they need to get on board and they need to graduate as many STEM graduates as they can. So looking at this, look at China, look at India, look at the United States. It stands to reason that if things continue, they're going to continue to, on the path that we see here, with all these engineers and scientists graduating, they're going to make great contributions in those countries. And that will advance their standard of living. But it also can threaten our standard of living. We need to have as many people as possible get into STEM careers of one type or another to help sustain the standard of living that we all know and love and appreciate and frankly take advantage of. China outnumbers us right now 8-to-1 in STEM graduates. So the future, as you see here, is quite bright for STEM graduates. These numbers, by the way, are in thousands. So total employment, total occupations, this is from the US Bureau of Labor Statistics. 162 million people employed in all occupations in the US in 2019. They're projecting 168 million in 2029. But the STEM occupations, roughly 9.9 million, going up to 10.7 million. There's an 8% increase projected in STEM occupations. All other non-STEM occupations, only 3.4. And look at the difference in the median wages. Roughly 40,000, 87,000. Those are median wages. You have to take that, of course, with a grain of salt, because there are other people in non-STEM occupations that make, a very, very good living. But the point I wanted to highlight here is there's a lot of opportunity in terms of rate of growth and in terms of the standard of living that you can establish for yourself at those income levels. Here again, if you look at the wages for the various kinds of fields, ag, business, communications, computer science, and so on, you see engineering is up at the higher end. And this chart just breaks down the different areas of engineering. You see aerospace, chemical, civil, computer, and so on. It's a great way to make a nice living. So what's Broadwind? Broadwind is a heavy manufacturer. We build gearing. We have 3 different divisions I'll talk about in a minute, but I'm trying to watch my time as well here. Our largest facility is located in Manitowoc on the Manitowoc River. This peninsula that you see here used to be Manitowoc Cranes and Manitowoc Shipbuilding. Now we build wind towers and a lot of other large fabrications. For those of you that are familiar with the Acuity Insurance Facility on I-43 by Sheboygan and has that monstrous flag, we designed and built that flagpole. This is a very interesting hydropower unit, small scale hydropower. It's called restoration hydropower, and it's for generating electricity with the flow of water. And there's the watersheds across the United States and really globally. They're looking at restoring watersheds that have been either destroyed or dramatically altered through development. And these are small scale hydro turbines that are going to be used for that. This happens to be a prototype of the very first one built. It was installed in December in Oregon. We built and assembled this entire unit. Very, very large shovel here, large fabrication. You can see it relative to the size of this semi-trailer. And in this view, you see what's becoming a very large crane for the Navy that's being assembled actually right here on the peninsula. And that's the first of many to come. So a wide variety of heavy manufacturing and types of fabrications that we get involved in. Broadwind has 5 locations around the country. We have one in Manitowoc, Wisconsin, a gearing division in Cicero. We have another fabrication division in Texas, a heat treating facility in Pennsylvania, and a kitting operation primarily serving gas turbines in North Carolina. So towers and heavy fabrications, that's what you see here in Manitowoc. Gearing is in Illinois and Pittsburgh, and then process systems is in North Carolina. Here's a few more examples of large fabrications that we do. I don't know if you can see behind me on my office wall. You probably don't because you're looking at my screen right now, but there's a picture of the Littoral Combat Ship up in Marinette Marine. Broadwind produces some of the large fabrications for the propulsion system for that ship. We are involved in the natural gas industry, providing pressure reducing systems. This is something that we design and build and do that down in our Texas facility. This actually is a tower section for the largest wind tower in North America that we finished up 2 years ago. It's installed in Texas. And this is a very large arm for a mining shovel. Lots and lots of welding, fitting, assembly work, painting work, mechanical and electrical assembly, all skilled trades. And skilled trades is a great place to make a living as well. And I think that, you know, all of these things that you see in these pictures all originated with engineering work to design all of this, plan the manufacturing processes, establish manufacturing processes, and bring this all ultimately to fruition in finished products that you see here in these pictures. So a day in the life, I don't intend to read this entire slide. You can do that later when you can download. But you know, there's a tremendous variety of things that you do throughout the day. I mentioned a few things earlier, like collaboration and multidisciplinary teams. You know, you're doing a lot of analysis type work of designs and specifications. You are looking at the manufacturability of something, whether it really can be made realistically or not, and what that might cost. You're looking for, maybe you're doing some design work on the computer with CAD, which is probably one of the things that most people stereotypically associate with engineering, working at a computer designing something. There's just so much more than that in the day of an engineer. And yes, you do attend meetings. And yes, you do have to write documents. And yes, you do create spreadsheets. You interact with a lot of people. Just tremendous variety of challenges. So the other thing I wanted to close with here is, please keep in mind, as you can see here, that career success, yes, it is very important, but it's got to be balanced with your overall life goals. And we all have our own definition of success. That's true. But it's not about success in a very narrowly defined space. You need to achieve this overall holistic balance or goals around health, your family, your personal interests, and your recreation. It's not just about salary and job title. Please don't make it that, or you'll find yourself unhappy no matter what you choose to do. And with that, I'll close. I'm wrapped up, and we can have some questions.
Yeah, I guess I'm going to throw a comment and a question to both of you, and I think we're just about right at about the 30-minute mark after that. But the comment is, I think Dennis really echoed what a young man named Mike Zemer, who works in the Lakeshore area as an engineer, said a few years ago. As far as engineering, you know, the misconception that you're just being nerdy, crunching math all the time. You know, Mike's comment was, you don't have to be a math nerd all the time. You just have to have the ability to get nerdy when you have to. So there are pockets when you have to, you know, do the equations and get there, but that's not, you do so much more, much like Dennis said. So you all said almost the same things. I guess my closing question to both of you is, picture yourselves, and I know you have some kids of your own, picture yourselves talking to your niece and nephew that is 15, 16 years old, and has some interest in engineering, design, computers, or the skilled trades. If you had to give just one piece of advice, just one piece of nutshell advice, and I know it's kind of hard, what would that one piece be? And either one of you can go first.
I guess I would say that, can you hear me?
Yeah.
I would say that if your true passion is creative discovery and solving problems, and you like the variety and things like that, and you are interested in how things work or coming up with new ways to solve interesting problems today, and you feel like you don't have a lot of confidence in the analytical skills, don't let that hold you back. There's a lot of help out there to help you through all of that and get through it and get through the education. And once you get to the other side, you'll be glad that you put that effort in. It's That's the stereotype that I really want to break down.
Thank you.
All right. Well, my response might be a little bit different, just in that I'm a firm believer in, get excited about whatever it is you're going to do, right? So if you can get excited about engineering and what it means to design and build things, it certainly sounds like an opportunity. And the things I've told my own kids, I have 4 kids, part of them have engineering degrees, part of them do not. But what I've said is, understand what's important. And it isn't necessarily the school you pick. It isn't necessarily the grades that you get. It's the accomplishment that you make. It's doing what you set out to do. Understand where you're headed. Be as grounded as you can be. Be true to yourself. Pass the classes, right? Get the degree. If your goal is to work in a really high-profile job at a very high-profile company, okay, the better school and the higher grades might be more important. If your job is your goal is just to have a job in engineering, right? Maybe the school isn't as important, as long as you get through the engineering program and you learn things from it. Really, that's the most important thing. My motto is define, execute, track, right? Lay out what it is that you want to do, execute that towards that plan, and then go back and track your accomplishments. And if you want to be an engineer, my opinion, you need to think that way. There might be some other professions that don't require that, but engineering is a very methodical field, and that's an important part of it. And stick-to-itiveness is key from my perspective.
Yeah, totally agree, Mark. Good points.
Excellent. Excellent. Well, thanks, Mark Dennis. We appreciate you very much, not just your time here in this 32 minutes, but the time preparing all this and the time, I guess, in probably most of all, caring enough about the young people in the area to do both the preparation and the presentation. So just appreciate you very much.
Very glad to be here. Thank you.
Yep, excellent opportunity. Anytime we have a chance to help the young kids or really anybody who's trying to break into an engineering field, all for it.
Okay, thank you.
Thank you.